welcome back to another professional prep video. In this video, we are going to learn about concavity. So we've already touched on what makes a function increasing or decreasing in regards to the first derivative. So we're going to start giving some importance to the first and the second derivative in this video as we talk about concavity. So by concavity, I mean, is the graph of a function concave up or concave down on a certain interval? So in this case, we're being asked the question, when is G concave up? So as you know, we like to learn by examples here at Professional Prep. So this is an example graph. I apologize for the drawing here because I know that it's not perfect by any means, but each little dash is supposed to represent 1. So this is the point 1, 2, -1, -2, etc. And this is our graph of the first derivative, or G prime. So when is G concave up? So concavity is, I like to think of it as an addition to increasing or decreasing. So when G is concave up, two things have to happen. G prime is increasing. When the graph of the first derivative is increasing, the graph of the original function is concave up on those same intervals. So obviously, G prime would have to be increasing on the intervals where G is concave up. And the other thing, and this you can sort of already tell based off of our previous video about increasing and decreasing. It's an add-on, but it's also very important. G is also concave up when G double prime, is positive. So when that second derivative is positive, the first derivative is increasing, because that's one derivative before the positive, which makes G concave up. So from here it's quite simple, but this is very important in calculus about concave up, increasing, and positive for those derivatives. And the other thing that you'll have to know, for concave down, it's the exact opposite. When G is concave down, G prime will be decreasing and G double prime will be negative. So now that we know this content, it makes solving this problem pretty simple. So we're looking for open intervals where G is concave up. Maybe I should say where is G concave up, but same thing here. And that's going to happen. Let's take a look at our graph of G prime. Now remember, this is very important. Look at whose graph it is. This is the graph of G prime, which means that that needs to be increasing by this statement right here. So where is this function increasing? Well, we're increasing from here to here, which is -4 to -2. Again, I apologize for the bad drawing, but there's one open interval. Now we're going to be decreasing all the way down to the point 2 here, but then from 2 up to 4, we are going to be increasing again. Or excuse me, that's supposed to be up to 5. Let me draw that a little bit more. Yeah, there we go. So from 2 up to 5, you can see that G prime is increasing and therefore G is concave up. And another interesting thing about this is that on each of these intervals, G double prime is also positive. But we already learned that as an extension from our last video about increasing and decreasing functions. So this is our final solution for where G is concave up. We want to pay attention to whose graph we're given. If we're given G prime, we look for increasing intervals. If we are given G double prime, we look for positive intervals. And if the question were, where is G concave down? Just to give us an example of that, I'm going to write it in here. So G is going to be concave down, like I said, where G prime is decreasing and where G double prime is negative. So, and that's just reverse from here. And so we are given G prime, so we're looking for where G prime is decreasing, and that is indeed going to happen from -2 to 2, the interval that is not mentioned in the solution of concave up. So these are not difficult problems to do once you understand the concept of concavity, which is just simply an extension of increasing and decreasing functions. So I would just make sure that you understand that g prime is increasing and g double prime is positive when g is concave up, and that g prime is decreasing and g prime is negative when g is concave down. But other than that, that's all I have for you on this video for a concavity. Our next video is going to talk about an extension using the second derivative in concavity, which is going to be points of inflection. This is another very important topic in calculus, which I'm excited to cover in our next video. Please make sure that you email if you have any questions or leave a comment below, and I will see you all for our next video. Have a great day, everyone. Thank you.